Dear students, we are going to discuss some waves, common issues related to the wave topic. Here is a question. State the difference between a stationary wave and the progressive wave in terms of the energy transfer. In a progressive wave, the energy always transfers from one place to another place in the direction of wave motion. But in the stationary wave, energy does not transfer from one place to another. It converts from one form to another form within the loop. ये इस किस्म की बात आप कर सकते हैं. The phase of two adjacent vibrating particles, progressive wave के अंदर जो adjacent particles हैं उनके बीच में phase difference exist कर रहा होता है, लेकिन stationary wave में 0 degree phase डिफरेंस होता है और 180 डिग्री फेज डिफरेंस होता है एडजेसेंट लूप्स में. एक्चुअली मैं ये बता रहा हूँ आपको, आई एम नॉट फोकसिंग ऑन देम 2 पॉइंट्स. मैं आ रहा हूँ यहाँ पर इस जो कैलकुलेशन बेस्ड क्वेश्चन है इनके ऊपर. अ ट्यूब इज़ ओपन एट बोथ एंड्स. ये बोथ एंड ओपन जो ट्यूब है इसकी दोनों साइड के ऊपर एंटी नोड्स बने हुए हैं. अगर ये ना भी गिवन हो और साउंड ऑडियोबल हो तो दिस मीन्स दैट देयर आर एंटी नोड्स. तो हर एंटी नोड्स के आगे एक नेक्स्ट नोड होता है एंड है यू गो. तो हम इस डायग्राम को क्वेश्चन स्टडी करने से पहले ही हम इसको फिगर आउट कर लेते हैं कि ये बेसिकली कैसे बनते हैं. ये आपके पास नोड्स, देन यू हैव एंटी नोड एंड देन यू गो टू द नोड. here you go and here we are and similar kind of essay. ठीक है. So यहाँ पे here we have nodes. This question is completely on stationary wave, so we must recall our knowledge related to stationary wave. If you see here, there is a 1/4 of the wave, then there is another quarter of the wave, then another quarter of the wave. And if you are smart enough, then you can see that this is 1.5 lambda, 1.5 lambda. And there are 4 quarters in a wave, 1, 2, 3, 4. There is a complete wave and then there is a half wave. So that shouldn't be an issue. 1.5 lambda is equal to 0.60 meter, then lambda will be equal to 0.60 over 1.5. That comes out to be 0.4, I guess. 0.6 divided by 1.5. That is 0.4. That is at the moment, this is ये जो इस फ्रीक्वेंसी में साउंड राइज हो रही है, दैट इज़ अ पर्टिकुलर फ्रीक्वेंसी, उसकी करस्पॉन्डिंग वेवलेंथ जो है दैट इज़ m. साउंड कैन बी जनरेटेड ऑन डिफरेंट फ्रीक्वेंसीज, तो फिर शेप ऑफ द वेव चेंज होगी. ठीक है. सो व्हाट इज़ द मिनिमम पॉसिबल कंडीशन कि यहाँ पर वेव ऑडियोबल हो जाए. तो उसके लिए मैं आपके लिखा, तो वो भी क्वेश्चन एंड पे मेंशन है ये वाला. सपोज दैट इज़ ये हमारे पास है, ये ट्यूब है, इसी ट्यूब की रेप्लिकेशन मैंने बनाई है. दिस इज़ 0.6 मीटर और इसमें लोवेस्ट पॉसिबल कंडीशन क्या ऑडियोबल साउंड की. देयर इज़ एन एंटी नोड हेयर एंड एट द मिड देयर इज़ अ नोड एंड दिस इज़. इससे लीस्ट पॉसिबल चीज़ जो ऑडियोबल नोट है वो एग्जिस्ट नहीं कर सकता. ठीक है. सो दिस इज़ एंटी नोड. दिस क्योंकि हमने कहा है कि जो ट्यूब बोथ एंड ओपन होती है उसके दोनों साइड्स के ऊपर एंटी नोड्स ही बनते हैं. दिस इज़ द लोवेस्ट पॉसिबल कंडीशन. तो ये जो लोवेस्ट पॉसिबल कंडीशन है इसके अंदर ये लेंथ तो है 0.60 मीटर, लेकिन अब वेवलेंथ जो है दिस इज़ हाफ, दिस इज़ 1/4 एंड दिस इज़ 1/4. So 0.5 lambda is equal to 0.6. So lambda will be equal to 1.2 meter. This is the largest value of lambda possible here in this scenario. So largest possible value can lead towards the smallest frequency. So if you want to measure the smallest frequency, you use V is equal to F lambda. V is the speed of sound. Now you will feed lambda here 1.2 and speed of sound is somewhere here, that is 340, and you get the smallest possible frequency. So ये तो इस मेन केस के जो डिफ़िकल्ट पोजीशन पॉइंट्स थे, वी डिस्कस ऑलमोस्ट ऑल ऑफ देम वो जो क्वेश्चन के अंदर है. Let's read out properly the questions pattern here. So what is meant by antinode and the stationary wave? Antinode has largest displacement, the point where the particle has the largest displacement. State the distance between node and adjacent antinode. That is always a quarter a wavelength. If your wavelength is a half a lambda, ऊपर आपकी wavelength जो थी उस that particular scenario में wavelength was 0.4, so here the distance is 0.1 meter. For the speed of sound, calculate the wavelength. You can calculate the wavelength जो हमने पहले ही calculate किया हुआ, that is 0.4 or 0.1 multiplied by 4. A wave have 4 quarters, so it has a wavelength of 0.4 meter. Its frequency, it's a stereotype question. You just feed the value and get the answer. That was the point which was basically belongs to your skills related to A star. That really challenged you. Determine the minimum frequency. Minimum frequency belongs to max wavelength. And max wavelength in a two-side open pipe is always of that pattern. Half a lambda is equal to the length जो given होगी. If let's move to some other concept. If the tube is one end open, then here is the only possibility of antinode, which is 1/4 of lambda. Then lambda will be much larger in one end open pipe rather than on two end open pipe. तो अगर question two end open pipe का है तो somewhere there is a possibility कि examiner can exercise this one end open tube and ask you the minimum frequency. तो here you go with that sort of largest wavelength and then go for highest frequency के तो कोई limit ही नहीं है, लेकिन मिनिमम फ्रीक्वेंसी की लिमिट है. सो दैट्स वाई क्वेश्चन हमेशा मिनिमम लिमिट का ही आएगा. ठीक है. सो आई हैव वन मोर क्वेश्चन दैट आई हैव फिल्टर फॉर यू. दैट इज आल्सो बिलोंग्स टू स्टेशनरी वेव. State conditions are required for the formation of stationary wave. The waves, two waves of the same type traveling in the opposite direction always meet. Opposite direction and meet or overlap, they are the key words. You should go with that. If the examiner asks for more marks, 3 or 4 marks, then you can add of the same type, same frequency, same speed. इस किस्म की बातें आप कर सकते हैं. ठीक है. You can say that a one wave and one reflected wave, they can also meet and cause a stationary wave. The horizontal string between two fixed points X and Y, the string is made to vibrate vertically so that the stationary wave is formed. Okay, जब एक stationary wave form हो गई है तो let's say मैं अपनी इसके ऊपर working कर लेता हूँ, try to be organize my all knowledge related to the diagram. That I think the student can go with these sort of question attempting techniques. When they see the diagram, yet they try to recall all of their knowledge before reading the question. I think that's how we can make a stationary wave that looks like that way. This seems stationary. Now I get two main points from this activity. One is here is a complete one wave, then we have two wave, then 2.5. So 2.5 lambda is equal to 2 meter. then lambda will be equal to 2 over 2.5. That gives you that is now a calculation process now. 2.5, that is 0.8. How you see that they are 2. Again, there is the distance between two nodes is a half a wavelength, then a half a wavelength, half, and then half. So you have 5 halves, means that you have 2.5 waves. Now there is one interesting thing appearing in here between P and Q. They are in two adjacent loops. In stationary wave, if the particle lies between two adjacent loops, their phase difference is always 180. If they lie within the loop, then their phase difference will be 0 degrees. So these are the only two conditions of phase difference in stationary waves. So let's start. State the number of antinodes in the stationary waves. Let's mark them where the displacement is high. That is one antinode. This is the second. This is the third. This is the fourth antinode. And this is fifth antinode. If I'm not making any mistake, 1, 2, 3, 4, 5 numbers are 5 antinodes. Antinodes क्या है? जहाँ पे आपकी वाइब्रेशन या एम्पलीट्यूड मैक्स है. Determine the minimum time taken for the particle P to travel from its lowest position to its highest position. Now that is not the time period. Time period, look at this. If you are here, you go up, then come down, then go down, and then go up. That is your time period. But if you are just pointing out up and down, this means you are referring a half of the time period. Lowest point to its highest point, this means half of the time period, because for the full time period it has to get back to the lowest position. So lowest position to the highest position, this is half a time period. And you can go with the help of the frequency, you can find the time period. T is equal to 1 over F. 1 over F means 1 over 40. And it gives us 0.025. And what about the half of the time period? That makes 0.0125. That will be the answer. The student may get confused on this कि वो time period पूरा क्यों नहीं ले रहे हैं. So the hint is given. It's for half a time period. State the phase difference between P and Q. I have gone through it. That is 180. Determine the speed. V is equal to F lambda. We have gone through 40 hertz. Lambda, that was 2 over 2.5, which was 0.8. So 40 into 0.8, you get the speed. So I think we have gone there is one more question which I want you to be well aware of that. All right. These are the just random stuff some student asked to me, then I just get this opportunity to make a video and just upload it to you people. I'm not getting that. Just hang on. Okay, I just take it from